In the earlier videos on my channel, we've looked at resistors, inductors, and capacitors, and with our knowledge about them, we have acquired the prerequisite knowledge that would allow us to be able to determine the um, current and voltages that arise when a capacitor or an inductor acquires or releases energy due to an abrupt change in DC voltage or current. Next, we are going to be focusing on circuits that contain resistors and capacitors, or circuits that contain resistors and inductors, but not circuits that contain resistors, capacitors, and inductors simultaneously. We call circuits that contain resistors and inductors RL circuits, while we call circuits that contain resistors and capacitors RC circuits. And for each type of circuit, we are going to be considering the step response of the circuit, and the natural response of the circuit. Suppose you have a fully charged charged inductor connected across a resistor, and it starts to discharge its energy across this resistor. The study of how it discharges its energy is called the natural response. It's also called the source-free response, because we are not connecting any voltage or current source across the terminals of the energy storage device. But in the case where we have a power source connected across it, then we are now looking at what we call the step response. That is when we now consider the behavior when there is a voltage or current source influencing the behavior of the circuit. This could be a capacitor, this could be an inductor, as long as it is an energy storage element. Now, the reason why we call RL and RC circuits first order circuits is because the equation that are needed to analyze such circuits they tend to come in form of a first order differential equations. Maybe they come in the form of L di dt plus IR equals 0, and other forms. So that's why we call them first order circuits, because they come in the form of first order differential equations. And when it comes to first order RL and RC circuits, there are four possibilities. There are basically four possibilities that your circuits can take. So here's how it is. You can have an inductor connected to a Thevenin equivalent circuit. That is the first form in which your circuit can take. You can have an inductor connected to a Norton equivalent circuit. You can have a capacitor connected to a Thevenin equivalent circuit, and you can have an inductor, a capacitor connected to a Norton equivalent circuit. Just keep in mind that when you are dealing with step response, VTH is greater than 0 or less than 0. But when you're dealing with natural response, VTH should be equals to 0, which would give you that equivalence of a source-free circuit. Same applies for all the other cases of first-order circuits. Also, you can also have multiple inductors and capacitors in your first-order circuit. They just have to be interconnected in such a way that they can be combined into one single equivalent inductor or capacitor in this circuit. So take for example, you had more inductors in parallel here, more inductors in parallel with this one. So you're just going to use the formula for combining parallel inductors, and then you replace this with the equivalent inductance. That's just how it is.